Hello everyone. So, our new topic is UV protective textiles. So, UV radiation protective textiles. In this section, we will discuss the different aspects of UV radiation. Initially, we will try to understand the UV radiation, then we will see the different factors in textile material which can affect the UV transmission performance or how to protect UV radiation, and last segment we will discuss about the fabric engineering, how to engineer fabric to control the UV transmission, ultraviolet ray transmission. So, first let us try to understand what is ultraviolet radiation. These are basically electromagnetic wave, and electromagnetic wave, if we classify, if we arrange in terms of wavelength, the wavelength from 10 nanometer to 400 nanometers, they are coming under the UV radiation, UV ray. So, first there will be cosmic ray, then gamma ray, X ray, UV ray, and above that it is a visible light, infrared and microwave. So, UV ray can be divided into 4 categories, again depending on the wavelengths from 100 to 10 nanometer to 100 nanometer, it is called UVD, then 100 to 200 nanometer UVC, 280 to 320 UVB, and 320 to 400 it is UVA ray, and depending on the wavelength their penetration through the ozone layer they take place, and their severity, that is the effect on human life, that also effect on the, that depends on the wavelength. These aspects first we will discuss. So, the energy, that wavelength, if we see that infrared frequency range from 3 multiplied 10 to the 12 to 4.3 multiplied by 10 to the 14 hertz, and UV light frequency range is in this range 7.5 multiplied by 10 to the power 14 to 3 multiplied by 10 to the 7 hertz. This is the frequency range. So, as I have already mentioned, so that ultraviolet radiation is classified into 4 categories depending on the wavelength as per biologist, UVA, UVB, UVC, UVD, and as per physicist they are classified into near UV, near ultraviolet, middle ultraviolet and vacuum ultraviolet. So, if you talk about the effect on human or any living organism, this classification is based on UVA, UVB, UVC and UVD. So, if you see UVA, so ultraviolet ray A, which is within the range of 315 to 400 nanometer, its energy is 3.1 to 3.94 electron volt. So, energy here it is lowest energy, but wavelength is high. As the wavelength reduces, the energy increases. So, it is a long wavelength, it is not absorbed by the ozone layer. So, majority around 90%, 95% it penetrates through the ozone layer, but here the energy is least. UVB, it is from 200 nanometer to 350 nanometer, it is a medium wave mostly absorbed by the ozone layer. Here they absorb by the ozone layer, and its energy is little bit higher than UVA 3.94 to 4.43, and short wave, that is UVC 280 to 100 nanometer, it is 4.43 to 12.4 electron volt, and it is completely absorbed by the ozone layer. So, short wave length UV ray, it's they are absorbed, and UVD is much shorter wavelength, they completely absorb, they do not come to the earth. So, if you see here, so 5% is absorbed in UVA by the ozone layer. So, 5% of the energy is being absorbed in the ozone layer for UVA, but 95% reaches to the earth surface. So, we should be careful about UVA, because majority of the rays are coming to the earth surface. UVB is 95% is absorbed, very little comes to the earth, but here energy is higher than UVA, and that is why it is more dangerous than UVA, and UVC it is almost 100% absorbed. So, why do you need UV protection? It is basically it affects the human and aquatic ecosystem, even plants. So, on human, it is skin cancer, eye cataract, immune suppression, these are the effects. So, it affects on plant, environmental effect is there are effects on material. So, UV ray it affects the synthetic fiber, particularly nylon and even polypropylene, they get affected easily and reduce the mechanical characteristics or other characteristics. So, protection against solar UV radiation, its maximum between 10 to 14 hours. So, one should avoid direct sun from 10 to 14 hours. Other ways of protection like environment and legislation change, creation and popularization of global UV index by WHO. So, global UV index people must know, and depending on the UV index one should use UV protection, maybe UV protective clothing or different shades one can use. Change in environment by provision of shade or other UV radiation protective structure depending on the UV index. Personal protection also is required, using sunscreen, umbrella, hat or sun protective clothing when people are going out. So, in our discussion we will try to see how to develop UV ray protective clothing. The most commonly used terms are ultraviolet protection factor, UPF is the most commonly used term to show the level of protection by a fabric or any material. So, this is assigning a degree of UV radiation protection of fabric. Its inverse of UPF is that erythema weighted transmittance EWT. So, it is the UPF equal to 1 by EWT, and sun protection factor SPF, it is mainly used for sunglass or sometime for clothing. SPF also we can use. UV index is another term which are used for daily weather forecasting. UV index is basically its environmental term. It shows how much UV radiation is coming to the earth surface in that particular area. UV index depends on the altitude of the particular place and clouds in that zone. So, if it is cloudy, this will, the UV index of that particular zone will reduce, and vice versa. EPF, eye protection factor, it is mainly used for sunglass. So, there are different terms we must know: UPF, EWT, SPF, UV index and EPF. First, let us try to understand the UPF, ultraviolet protection factor. This is the ratio of average effective UV radiation irradiance transmitted and calculated through air and that radiation to the average effective UV radiation calculated through the fabric. Now, let us see, this is fabric and here there is no fabric, it is through air. Now, suppose UV radiation is coming, UV radiation, here also UV radiation. Now, here with the fabric, so without fabric, with through air, it is coming ED, and through fabric, fabric will absorb little bit UV ray and it will say ED fabric. So, ED is more than ED fabric, that is energy coming through the fabric. So, here the energy UV radiation energy, it is more. So, this will be more. So, UPF will be ED by EDF, which is more than 1. That means, higher protection, higher absorption by the fabric means the, if the absorption is high, that means the amount of energy transmitted through fabric will be low. So, where that is why if it is low, so if it is low reduced, then UPF will increase. So, fabric protection will increase. So, higher protection of fabric means higher UPF. So, effective dose of the UV radiation, its ED through air, or effective dose which is coming out from fabric after absorption by the fabric, it is EDF. So, UPF is equal to ED by EDF, I have already explained, and EWT which is reciprocal of UPF. So, that we can also derive. Now, the ranges are the UPF range, if it is 40 to 50, it is excellent protection, where only less than 2.5% transmission will, the UV ray will get transmitted through the fabric. rest 97.5% or more will be absorbed. So, these are excellent, anything more than 40 UPF is excellent. So, UPF rating 40, 45, 50, 50 plus like that. 50 plus is very good ultraviolet protection rate. 25 to 39 it is a very good protection, where 4.1 to 2.6% of radiation is getting transmitted. So, 25, 30, 35 in this way we express the UPF, and 15 to 24 is good protection, and below that it is a poor protection. So, 15 to 24 means typically 6.7 to 4.2% are getting transmitted. Next is the sun protection factor. These are basically used for any sun protective lotion and sometime for fabrics. Sun protection factor is actually it is a ratio of dose to produce minimal sunburn under fabric cover or maybe sun lotion cover to the skin, to the radiation dose to produce the same sunburn of uncovered skin. Now, so this is one skin, suppose human skin. Here we are protecting through one cloth, another human it is without any protection. Now, we will keep on increasing the radiation rate. Here certain time, after certain time mean dose, mean effective dose without any cloth is MED, and mean effective dose with protective surface is this one. Now, here with mean effective dose, certain mean effective dose, there will be a sunburn after certain time. But here if we want to have similar sunburn after protection, we need to increase the mean effective dose. So, mean effective dose here is more than dose without surface, unprotected surface. So, this is that is why sun protection factor SPF, which is more than 1, is equal to this one is more. So, MED protective surface by unprotected skin. So, this is a protective skin, protected skin and unprotected skin. The ratio here shows the sun protection factor. The main difference from the earlier one, UPF we do not need any human object, but to measure sun protection factor we need human object, and this SPF is very important for sun protective lotion, where we have to use our body part and apply the lotion on the body part, and after that we try to see any sunburn. So, MEDPS is minimum erythemal dose of protected skin. So, PS, that is maybe by fabric protection or by any lotion protection, and minimum erythemal dose of unprotected skin MED/US, that is without any protection. So, MED is defined as minimum quantity of radiant energy, that is its UVB dose. Here we normally use UVB dose required to produce fast detectable readiness of the skin, and its time is 22 plus minus 2 hours exposure. So, that exposure will be in continuous manner, and then we will measure the skin readiness. So, skin will get red. So, when as soon as the skin reddening will happen, then we will stop our experiment, and we will keep on change. If the skin reddening is not happening, then we will go to the next level of dose. In this way we will do experiment, and ultimately we will calculate the SPF. SPF measurement is basically time consuming measurement, whereas UPF we can get immediate result. Now, try to understand UV index. For all this study of UV protection, we must know the UV index of that particular environment. So, without UV index, only developing UV protective clothing will not help. We need UV protective clothing where UV index is very high. In case of low UV index, we have to produce fabric accordingly. UV index is an international standard which measures the strength of UV radiation from the sun at a particular place at a particular time. So, that is important. UV index changes with the place, altitude, many other factors are there. So, this index is actually open ended linear scale. That means, it is directly proportional to the intensity of UV radiation that cause sunburn to human skin, which means that we can extrapolate. For example, if an individual without sunscreen begins to sunburn in 30 minutes with UV index of 6, then we can predict that same person will have the same effect of sunburn in 15 minutes with a double intensity of UV index of 12. If the UV index becomes say 3, then he may take 1 hour time to have similar sunburn. So, that is why it is called, it works on linear fashion. So, UV index represents the maximum effective radiance received on the skin surface, taking into account cloud cover and all other variables of the environment. So, we must know the UV index, and that is the maximum radiance which is reaching on our skin, and this radiance UV index is, it is a combination of UVA, UVB, UVC, everything. If you take care, whichever it is coming accordingly and giving the weightage of different ray, that I will explain just now, and then we calculate the UV index, and it is obtained by multiplication of the effective radiance of the solar radiation by 0.04. But typically if you see, it is if we multiply by 0.04, that means we have to divide by 25 basically, whatever the UV radiation comes, and if we multiply with the weightage, and then if we divide. And why do we divide by 25? Just to have one value within a scale of 1 to 11 or 1 to 15, that particular value if we want to get, that is why we divide by 25, otherwise the value will be very high. That is the standard. We can also use total radiation coming into the body, but to have the scale from 1 to 11 or 1 to 15, in that scale we have to divide by 25. Now, if we see the UV index 1 to 2 UV index, it is a weak UV index, weak. So, it will not be that much harmful. So, continuous exposure of 1 to 2 hours, 2 to 3 hours is, we can have that continuous exposure without any effect. UV index 3 to 4 means moderate, where exposure of 40 minutes to 1.5 hour. So, 1 hour 30 minutes, that is possible. 5 to 6 it is a strong, so exposure of 25 to 50 minutes, and 7 to 8 it is very strong, continuous exposure of 20 to 40 minutes duration, where sunburn can occur. Okay. So, this time, during this time, if it exceeds, then sunburn will occur, otherwise without any protection we can have this. So, before we go into the sun, if we know the UV index, then we can use our protection accordingly. So, anything above say 8, these are dangerous. As I have mentioned, UPF is basically without any human object, it is in vitro measurement, where it is a ratio of ultraviolet ray coming. This is without any protection in air, and this is through the material, protective clothing or any sun protection lotion. We can calculate the UPF, and one thing we should mention here, these are the energy and wavelength, but this multiplication here, its E lambda is relative erythemal spectral effectiveness, S lambda solar spectral irradiance, and delta lambda measured wavelength interval in nanometer. So, here if we see lambda ranging from 280 to 400, these are the ranges which are coming through the ozone layer. SPF measurement needs the human object, because we have to see the skin readiness, generally used to determine the SPF of sunscreen, requires human subject based on minimal erythemal dose MED. So, radiation dose to produce just perceptible erythemal under fabric cover or any other sunscreen cover, and divided by the radiation dose to produce just perceptible erythema of uncovered skin. So, for at certain time this radiation dose we change, and then we measure the dose intensity. Now, coming to the calculation of UV index, this is a standard method followed internationally to know the UV index. So, if we listen that it is a UV index for a particular city is set 5, so what does it mean? So, when calculating how strong the UV radiation is in a particular place, scientists only focus on the range of wavelength between 290 nanometer to 400 nanometer, since this range of UV passes through the ozone layer. The range of ozone layer, those which are absorbed, those are not taken into account, because those are not reaching to the environment. Now, the strengths are arbitrarily given for different wavelength of UV. So, 290, 320, 400 we can subdivide also, and strength is 5, 25 and 50. The stronger, the shorter wavelength, are absorbed by ozone more than the longer. So, their strength near the earth surface is weaker. So, depending on the wavelength, so these are absorbed by ozone layer maximum 290 nanometer wavelength. So, that is why their strength arbitrarily given lower, whereas longer wavelength they reach to the earth surface maximum. So, that is why their strength is given higher. So, this strength is based on the absorption of this UV rays by the ozone layer. These values what we have seen earlier 5, 25, 30, these are hypothetical value and may not be exactly identical to how different agencies calculate UV index. So, different agencies are there to calculate UV index. So, different agencies they may give slightly different value, but having the strength weighted with the smaller value for shorter wavelength is accurate, because shorter wavelength reaches minimum quantity to the earth, because they are maximum absorbed by the ozone layer. So, for any calculation, if the values hypothetical values are different, but their trend will be same. And then the third column added, which is given weightage. Here if we see, the weightage are just reversed to that of strength 290 nanometer. The strength was 5, because its amount proportion reaching towards earth after absorption was 5, but weightage shows the its severity on the human health or any other matter. Lower wavelength is more harmful than the higher wavelength. So, as the wavelength increases, this weightage is depending on the harmfulness. So, these are 29 nanometer, so 290 nanometer wavelength are very harmful, that is why they are given higher weightage. So, scientists found that shorter wavelengths are more dangerous, okay, because they have got higher energy. So, shorter wavelength with higher energy are more dangerous towards human health. To include this, and this shorter wavelength also affects the material at higher rate. To include this information in calculation, weighting the UV strength at different wavelength is required. So, that is why it has been weighted. So, weight of wavelengths is opposite fashion as the strength of the values given earlier. Okay. Shorter wavelengths have a higher weight because they are more dangerous, but lower strength factor since they are absorbed more by ozone layers. These values are theoretical and they are weighted in accurate fashion by different agencies. Then what we have to do? We have to multiply the strength with the weight. So, we get result 85 for 290 nanometer, 175 for 320 nanometers and 400 for 70 nanometers. So, this result is a combination of amount and its effect on human health or any effect on any material. So, it is a quantity and the energy multiplication. After doing so, what we have to do? We have to add to get the total radiation. So, multiply the strength of UV by weight and the result will be UV radiation's direct strength at the corresponding wavelength. So, this result is direct strength of the UV. Say 85 is the direct strength of UV of 290 nanometer, and after that what we get? So, we have to add the results. The strength of UV at each wavelength from 290 to 400 nanometer is summed up to represent the overall impact of UV radiation has on the human skin. So, what we get? We get, if we add, we will get 330 is the value. Then the 330 value, if we divide this 330 with 25, then we will get the UV index for that particular place. So, before doing that, what we do? We can take into account two aspects. One is the altitude aspect, another is the cloud cover, that if we want to incorporate, that we do, otherwise we can directly divide by 25. How the clouds and elevation interferes? So, it has been determined that for each kilometer above the sea level, there will be 6% increase in magnitude of UV. So, if it is 1 kilometer above the sea, it will be 6% increase. That means that we have to add 0.06 for every kilometer. It is also known that UV radiation is absorbed by clouds, okay, with which reduces the intensity of UV ray which is coming towards earth. According to environmental protection energy, they have different standards. When there is no cloud, there will be 100% UV ray coming to the earth surface, which is coming through the ozone layer. So, there is no restriction or reduction, but for spotty clouds there will be 89% transmission, and completely overcast sky there will be 31% reduction. Then the 30% will reach, and typically that 69% will be absorbed there. So, if you take these two aspects of elevation and cloud interference, we can readjust the data. So, let us choose elevation of 5 kilometer with scattered cloud. So, if we try to see the UV index for a particular place, which is say for example 5 kilometer above the sea level, and its scattered clouds are there. So, to take the 5 kilometer, that means 6% for each kilometer, the true effect of UV would have to be adjusted 30% increase in elevation for the elevation. So, 6% increase in every kilometer. So, there will be 30% total increase in UV ray at that location, and 89% of that because of the scattered clouds. So, if you take both these two aspects into consideration, the calculation will be 330, which we have got earlier, 1.30, that means 30% increase due to the elevation, 5 kilometer elevation, and 0.89 means due to scattered cloud. So, it is coming out to be 381.81, and this 381.81, if we divide by 25, we will get 15.27, with a round off it will be 15. So, at that particular place the UV index will be 15, because this to have a whole number, okay, which is we can compare, and 0 UV index means there is no UV ray, and as UV index increases there will be more and more UV ray coming from the sun. So, increase in UV index, that means increase in risk. Okay. So, UV index 0 to 2, So, what are the protection required for different UV index of environment? So, 0 to 2. So, for that it is a lower threat, lower risk. So, cover head and or eyes. So, just by covering head or eyes we can be protected. We can cover by cap. 3 to 5 we have to cover head, eyes, and we have to use low SPF sunscreen. We do not need any other protection. Low sun protection factor sunscreen is enough. 6 to 7 we have to cover head, eyes, body, and we have to use strong SPF sun protection factor, that sunscreen we have to use, and we should not spend long time for in outdoor. 8 to 10 which is very strong, we have to cover head, eyes, body and use strong SPF or do not spend time in outdoor, and we have to take sufficient protective measure. So, we can use clothing with UV protection, higher UPF. So, UV protective clothing we must use during this, and above 11 we should not go out because it is extremely dangerous. Okay. So, accordingly we can select clothing, our protection. So, anything above 3 we should use our protective clothing. There are different standards available. So, European standard EN 13758, that is there are variants. So, 1, 2. So, Australian standard, ATCC, ASTM. So, different standards available to measure the UV protection in clothing. Now, we will discuss the effects of various textile parameters on ultraviolet ray protection. These factors are material related factor. We can use different materials for making textile for UV protection. So, if we see UPF of cotton, viscose and linen, these fibers give lower UPF than the synthetic fibers like nylon and polyester. Wool also, wool and silk, this protein fibers, they give higher UPF than the cellulosic fibers. Polyester provides usually high UPF. So, in terms of material selection, as far as UPF is concerned, so UV protective textile is concerned, we must use this type of clothing. So, polyester is preferable here. If we want to use cotton or viscose, we must use extra UV ultraviolet protective finish we can use. Porosity, areal density and thickness are also important. So, we can change the porosity of yarn and fabrics. So, with the increase in the porosity, the UPF decreases. So, if we increase the porosity, that means the fabric becomes porous. So, through that the ultraviolet ray will pass. So, UPF increases with the decrease in porosity and increasing fabric weight and thickness. So, as the fabric thickness increases or fabric mass per unit area increases, it will protect the UV ray. More thickness or higher weight means there will be more number of fibers coming into protect the UV transmission. Fabric dyed with dark color gives higher UPF value. If we use UV absorber as finish material, that will increase the UPF value. When we stretch the fabric, that means its pore size will increase and through which the ultraviolet ray can penetrate. So, UPF decreases. So, UPF decreases under stretch condition. So, stretchability of fabric we have to see. For say knitted fabric under stretch condition, it reduces the UPF value. With the wetness, UPF decreases when cotton becomes wet. So, through wet cloth ultraviolet ray can pass through easily. Washing increases the UPF. It means during laundering what happens, the fabric get actually that shrinkage occurs, shrinkage in fabric occurs. So, effective pores between the yarn reduces due to shrinkage. So, that effectively increase the UPF value. Here we can see number of laundering cycle here. If we increase the laundering cycle, the UPF value increases. So, UPF of clothing gets modified during laundering process. Most fabrics shrink after laundering and thus open area of fabric reduces, which in turn improves UPF value. There are various factors. Basically, the factors are raw materials that we have discussed, yarn related factors we have discussed. This yarn related factors are there, like type of yarn, yarn twist. So, they affect the UPF. And fabric related parameter, fabric geometry, there are two types of effects. One, primary effect. Primary effects are based on weave structure, yarn count and thread density. So, different weave gives different type of that UV radiation, UV protection. Yarn count, so finer count keeping everything constant. Using finer yarn count means more open area. So, that will allow more and more this UV ray to pass through. And thread density, if we want to prevent the UV ray to pass through, so we must use the compact thread density, the closer thread density. So, thread density should be high, and depending on the weave, yarn count and thread density, there are secondary factors which are dependent on the primary factors, like fabric cover factor. They are dependent on mainly yarn count and thread density, fabric porosity, fabric mass per unit area, fabric thickness depending on the yarn count, mass per unit area, again yarn count and thread density, and yarn crimp, yarn count, thread density and weave pattern. So, all these factors directly or indirectly affect the UV protective performance of textile material. So, in the next class we will discuss all these factors in detail, like raw material related factor, parameters of yarn, parameters of fabric geometry and technological parameters in detail. So, till then, thank you.